Alright, so we're going to start using piecewise functions to model word problems or real-life applications. And so I want to look at this first example. And it says, use a piecewise function to represent the following situation. A gift shop sells pewter mugs for $35. They are currently running an engraving promotion. The first 6 letters are engraved free, and each additional letter costs 20 cents. So we want to write a piecewise function to represent that situation. And so I'm going to start out by thinking about how many different options there are. So it says the gift shop sells pewter mugs for $35, and they're running an engraving promotion, and the first 6 letters are engraved free. So each additional letter costs 20 cents. So no matter what, you've got to pay $35 to get the mug. It's the letters that are going to cost you extra. So X is what's I'm going to let represent the number of letters. Okay, so it's the number of letters that I'm going to have engraved. And so if I have 6 letters or less engraved on that mug, my mug is going to be $35. So my first little category over here that I'm going to set up is if X is less than or equal to, I can get up to 6 letters. So less than or equal to 6. And then we also want to put on this, we want to make this a sandwich. I can't get a negative number of letters engraved, so I'm going to say it also has to be greater than or equal to 0. I could get 0 letters engraved, but I couldn't get -1 letters engraved. That doesn't make sense. So if I get those 6 letters, or something that's a word that's 6 letters or less, it's going to cost me $35 no matter what. So this is going to be the price of a cup or a mug that has 6 or fewer letters. Now, if X is bigger than 6, it's going to cost me 20 cents per letter. So before we write the function or the equation or rule for that second piece, let's look at what it would cost to engrave East Surrey High School on there. So this is 4 letters, this is 5 letters, 4 letters, 1, 2, 3, 4, 5, 6. So this is 6 letters. So if I add all those up, that's 10, 19. So this is 19 letters. So now, if I go find the price of engraving this mug with East Surrey High School, I know I'm going to have to pay $35 for the mug no matter what. And I don't want to pay 20 cents for my first 6 letters. I should only have to pay for 19 minus 6 would be 13. And so I'm going to add to that 35 the 20 cents that I have to pay for 13 letters. And we found that by doing 19 minus 6. And so that gave me 13. And so the cost of engraving that mug, it would be 35 plus 0.2 times 13. So 30. 1 second. So 35 plus 0.2 times 13 would give me $37.60. Alright. So then the way that I'm going to write my formula back up here is by doing the exact same thing that I did down here. I don't want those first 6 letters that I get I don't want to have to pay 20 cents for those. So no matter what, I've got to pay the $35, but then I've got to pay 20 cents for the number of letters that I get after 6. And so the way that I would do that, the number of letters is represented by X. So it's like X was our 19 down here, so I'm going to take X and subtract 6 from it, and that's going to give me how many letters that I get over 6. And so this would be my formula that represents this. Alright, let's look at an easier one. This looks like it's a lot of text, and it kind of is, but it's really not that hard. I think this one's easier than the last one. It says a company pays its employees a combination of salary and commission. An employee with sales less than $100,000 earns a $15,000 salary plus 3% commission. I'm going to go ahead and write my equation for that piece. So let's see what X is going to be. I want you to always define what your variable represents. So it says an employee with sales less than $100,000. So this looks like it's going to represent the sales that an employee has. And so if an employee sells less than $100,000, and I would also want to say I can't sell negative dollars, so I'm going to say it has to be or equal to less than or greater than or equal to 0, because I can't sell less than that. And it would just be less than 100,000, so just less than here. I'm going to earn a $15,000 salary plus a 3% commission of everything that is a 3% commission on my sales. So I'm going to earn my $15,000 baseline salary and then 3% of my sales. So I would represent 3% of my sales by just 0.3, not 0.3, but 0.03 times X. So this would be 3% of whatever I sell, and then plus my $15,000 salary, and that's what I would earn. Now, if I have a sales, or if my sales are between $100,000, so I'm going to put, that's 10,000, 100,000 over here, and then up to $200,000. And so I need an or equal to on this also, because it says with sales of 100,000 to 200,000, so it can go all the way up to 200,000. I'm going to earn an $18,000 salary plus a 4% commission of whatever I'm going to sell, of my sales that I make. And then my last one, this is an employee who earns more than $200,000, so it's not going to be greater than or equal to, because our last one was equal to. So if I earn more than $200,000 in sales, then I make a $20,000 salary plus a 5% commission, so that would be 0.05x. And so here's our piecewise function that would model the pay of an employee with X in annual sales. So X is sales. Alright, and so then that's my function. Alright, this one is more like the first one. So it says, each orange tree in a California grove produces 600 oranges per year if no more than 20 trees are planted per acre. So for each additional tree planted per acre, the yield per tree decreases by 15 oranges. We're going to write a function that describes the orange tree yield for this particular grove. So I'm going to go ahead and write f of x. Now, my x is going to be, let's look at our categories first so we can figure out what x is. It says no more than 20 trees are planted. So this x would have to be less than or equal to 20. And x would have to represent the number of trees, and this is planted per acre, number of trees per acre. Alright, so we couldn't plant a negative number of trees, so I would also put 0 on this side. So each orange tree in a California grove produces 600 oranges per year if no more than 20 trees are planted. So if the number of trees are in between 0 and 20, each tree is going to produce 600 oranges. So I would say 600x here. So 600 per however many number of trees I have in that acre. Now, if I plant more than 20, so if I plant more than 20, if x is greater than 20, then the yield per tree decreases by 15 oranges. So we want to write a function that models that. So if I plant more than 20 trees per acre, then they're not going to produce the same amount that they did with only the 20 there. So I need to know how much they're going to produce if there's more than 20. So what I'm going to do, it says for each additional tree planted per acre, the yield per tree decreases by 15 oranges. So I'm going to figure out how many oranges these 20 trees would produce, okay, first. So 600, I would do 600 times 20, and that would give me 12,000. Now, I know that each tree, for each additional tree planted over 20, it's going to go down, that number is going to go down by 15 per tree. And so I want to know how many number of trees over 20 that I plant. So I would say 15 times, this next little parentheses is going to represent the number of trees that I plant over 20. And so if I planted 22 trees, I would plant 2 more than 20. And so the way I would find 2 is by saying 22 minus 2. And so I'm going to take the number of trees that I plant and subtract 20 to find out how many more trees over 20 I planted. And then I'm going to times that by 15 because it's decreasing by 15 oranges per tree. And so then this would be my formula for that. And then that's it. Alright, so we've got 2 more. It says, in the state of North Carolina, if you make $12,750 annually, you will pay a 10% state tax. If you make at least $12,750 but less than $600 annually, you'll pay a flat fee of $765 and a 7% tax on every dollar over $12,750. If you make at least $60,000 annually, you'll pay a flat fee of $4,072.50 and a 7.75% tax on every dollar made over $60,000. So we want to write a function that models the tax brackets. So f of x equals, x is going to be the amount of money that you make, or your salary. Alright, so it says our first category is if you make less than $12,750. So I'm just going to write x is less than $12,750. Then you're going to pay a 10% state tax. So I'm going to say 0.10 times x. You just pay that flat 10% rate if you make less than that. Now, if you make at least, okay, so that means that this side of the sandwich is going to be $12,750. And then the other side, it says less than $60,000. Then I'm going to pay a flat fee of $765. So I'm going to pay that $765 and a 7% tax. So that would be 0.07% on every dollar made over $12.75. So I want to find out how much more I'm making than $12,750. So I would find that by taking the salary that I make and subtracting $12,750 from it. Because I don't want to pay the 7% on everything I make. I just want to pay the 7% on what I make more than that. So then that would be my formula for that. Now, for the last bracket is if I make at least $60,000 annually, so that's x is greater than or equal to 60,000. I'm going to pay a flat fee of $4,072 and then a 7.75, so that would be 0.0775 on every dollar made over 60,000. So I would find that by doing x minus 60,000. And then that would give me the amount of money that I make over 60,000, and then that's what I'm going to pay the 7.75% tax on. And so then here's my function that models that. Alright, last one. It says a fabric store sells fabric for $8 per square foot for the first 20 square feet purchased, and then lowers the price to $6 per square foot after the first 20. Write a function that models this situation, and then we want to use that function to predict the cost of a tablecloth. That should be 5 by 10 foot long. Alright, so the first thing I'm going to do is say what x is, and x here is just going to represent the number of square feet of fabric that I buy. And so then my function, my first option is if I buy 20 square feet or less. So I'm going to say x is less than or equal to 20, and then I'm also going to say I can't purchase a negative amount of fabric, so I have to set that on the other side 0. So it's $8 per square foot. So that would just be 8 times x for the first 20 feet. And then after I buy my first 20 feet, the price is going to be lowered to $6. So for this next option or category, I'm going to have x is greater than 20. And so then I'm going to pay $6 for all of the yards that I buy over 20. And so no matter what, I'm going to have to pay for this first 20 square feet of fabric. And so I would find the price that I would pay for the first 20 square feet by saying 8 times 20, which is just going to be $160. And then I would say plus $6 per square foot over 20. And so I would just say 6 and then x minus 20. And then I'll make a second video to finish this. It'll be a real short one to finish how we would do this piece to find or predict the cost.